This is Chemistry Podcast 6.5, and we're going to talk about percent yield. We're going to talk about what it means and also how you can calculate it. So the first thing we need to talk about is that normally when we're running a lab, what we get as our yield in lab, or what we produce as our products in lab, the amount we get is not usually the same as what we're predicting to get, what our calculated amounts were. The experimental is not equal to the calculated. And the reason why is a lot of things can go wrong in the lab. When we are running these stoichiometry calculations, we're pretending that everything is ideal, nothing goes wrong. But in real life, reactants can be impure or contaminated. Reactions a lot of times do not go to completion, so they don't run until something runs out completely. They stop beforehand. And there also can be side reactions. Once you start building up those products, reactions can occur between the products and the reactants. You can have these side reactions that you don't anticipate until the lab actually happens. So what we're going to do is we're going to talk about how you can calculate what your percent yield was when you did the experiment. How far off were you, or how close were you to what you should have got? The two terms you need to know are theoretical yield and actual yield. Theoretical yield is always what you get from a calculation. It's what you're expecting to get because it's what you calculated through stoichiometry. The actual yield is what is produced from running the experiment. So theoretical yield is your calculated amount, and your actual yield is what you got from doing the experiment. Here's the formula for percent yield. You take the actual, and the actual, remember we said, is from the experiment, and then the theoretical is from your calculations. So you take your experimental divided by your calculated yields, and then you multiply by 100. Here's our first practice problem. It says, what is the percent yield of the following reaction if 60 grams of calcium carbonate, so 60 grams of calcium carbonate, was heated and we produced 15 grams of calcium oxide in the lab? So this 15 grams of calcium oxide, that is the actual yield. We're going to use that when we calculate the percent yield here. But the first thing we need to do is calculate our theoretical yield. What should we have gotten of the calcium oxide? So we start with what's given, which is the 60 grams of calcium carbonate. We run just a regular stoichiometry problem. If you add up calcium carbonate, you get 100 grams on the periodic table, and that is 1 mole. And then from the chemical reaction, it's a 1-to-1 ratio. So 1 mole of calcium carbonate is 1 mole of calcium oxide. And the last step is grams. 1 mole of calcium oxide is 56 grams. And when you do the math, you end up with 33.6 grams of calcium oxide. Because I found 33.6 by doing stoichiometry, this is my theoretical yield. So this is your theoretical yield. Then to calculate your percent yield, so my percent yield equals the actual, which they gave us up in the problem was 15 grams, divided by what we theoretically should have got, which is the 33.6 from the calculation, and we multiply by 100 to make it a percentage. And 15 divided by 33.6 multiplied by 100 is 44.6%. So a little under half of what we should have got is what we actually produced in our lab. The next question we have is, how many grams of carbon dioxide did I make if I started with 20 grams of calcium carbonate and I had a 75% yield? So this question is a little bit different. Instead of calculating the percent yield, they've given it to us, we're asked to calculate our actual yield. What did we really get out when we ran the experiment? But it's going to start the same way. We do stoichiometry to start with. And I'm going to start with 20 grams of calcium carbonate this time. It's still 100 grams from the periodic table, and that is 1 mole. And then our mole ratio is still 1-to-1 because there are no coefficients up here. So 1 mole of calcium carbonate produced 1 mole, and this time we're doing carbon dioxide because it says that right here. And then 1 mole of carbon dioxide is 44 grams. So when I do that, I end up with 8.8 grams of carbon dioxide. Okay, that is my theoretical yield. That's how much I should have got. But I only got 75% of that. So if you want to set that up in the percent yield formula, it would be like this. 75% equals my actual. I don't know what that is. That's what I'm solving for. But I should have got 8.8 grams, and then we have to multiply by 100. So you end up getting 0.75 times 8.8. And when we do that, we get 6.6 grams of carbon dioxide actually produced. So quick examples of how you use the percent yield calculation. It's pretty important because you can realize how accurate or I guess how well your lab ran, how much of the product did you produce that you were supposed to. So they're very helpful. They can kind of analyze your experimental setup and see how you did. And that's going to be it for this podcast. So make sure you know the formulas and make sure you can tell the difference between the theoretical yield and the actual yield.